Download this code from codegive.com, link in the description below. OK, let's dive into 5 common GraphQL mistakes and how to avoid them, complete with code examples using JavaScript and Node.js, specifically, GraphYoga for a simpler setup, but principles apply to Apollo Server or other GraphQL implementations. Why GraphQL mistakes matter? GraphQL, while powerful, has a learning curve. Making mistakes can lead to performance bottlenecks, security vulnerabilities, and code that's difficult to maintain. Addressing these issues early saves headaches down the road. 1. Overfetching and underfetching data, and how to design for specific needs. The problem. The core promise of GraphQL is that clients ask for exactly what they need. Overfetching occurs when the server returns more data than the client requested. Underfetching means a client needs to make multiple requests to get all the data it requires. Both negate GraphQL's benefits. Root cause. Often, the schema design isn't tailored to how the client actually consumes data. Thinking in terms of database tables rather than user interfaces is a common trap. Example, bad schema. Problem. If a client only needs a user's name and ID, this schema forces the server to resolve email and posts as well. That's overfetching. Problem. Imagine a dashboard showing user details and the number of posts they have. The client might need to make 2 separate GraphQL queries, one for user details, another to fetch and count posts, which is underfetching. Solution, schema design focused on client needs. 1. Identify common use cases. Think about the different ways clients will consume user data. Full profile views, list views, dashboard summaries. 2. Tailor queries. Design queries and types that directly support those use cases. 3. Introduce calculated fields. Resolvers. Use resolvers to derive values that are not directly stored in the database but are frequently needed. Explanation. User summary query, returns only ID, name, and post count. Perfect for dashboard summaries. Clients don't fetch the unnecessary email or full posts array. User.postCount, a resolver on the user type that calculates the number of posts. This is useful if you sometimes need the post count along with the full user details. Client query examples. Full user details. User summary. Key takeaway. Think about the various UI components and data needs before designing the schema. Introduce specific queries and calculated fields to avoid over/underfetching. 2. N+1 problem, and how to use data loaders. The problem. The N+1 problem is a classic database performance killer. In GraphQL, it manifests when resolving a list of items, each of which requires fetching additional data from a database. Example. Imagine a query that fetches a list of users and then, for each user, fetches their posts. If you do this in a naive way, you'll make one query to get the users, and then n separate queries to get the posts for each user, where n is the number of users. Code example, N+1 problem. Observation. The console.log will show that a separate database query is being made for each user when resolving the posts field. This becomes extremely slow as the number of users grows. Solution, data loader, for batching and caching. Data loader. A library created by Facebook specifically to solve the N+1 problem in GraphQL. It batches multiple requests for the same type of data into a single request, and it also caches the results. Installation. npm install data loader. Explanation. 1. Batch get posts for users. This function simulates fetching posts for a list of user IDs. Critically, it takes an array of IDs as input. In a real application, this would involve a database query with a where user underscore ID in clause. 2. Data loader instance. We create a new data loader instance for each request within the context function of GraphYoga. This is essential to isolate data loading and caching across different user sessions. 3. User.posts resolver. Instead of directly fetching posts, we call context.postloader.load, user.id. Data loader intelligently batches these calls. Asterisk how data loader works asterisk. 1. Collecting keys asterisk when the user.posts resolver is called multiple times for different users within the same query, data loader doesn't immediately call batch get posts for users. Instead, it collects the user IDs. 2. Batching asterisk after a short delay, or when the end of the query is reached, data loader calls batch get posts for users with the array of collected user IDs. 3. Caching asterisk data loader caches the results. If the same user ID is requested again within the same request, it will return the cached result instead of making another database call. Asterisk running the example asterisk run the GraphQL query. You'll see that batch fetching posts for users 1, 2 is logged only once, even though the user.posts resolver is called for both Alice and Bob. This demonstrates the batching. Asterisk key takeaway asterisk use data loader to batch and cache database requests, especially when resolving lists of items. Create a new data loader instance per request by putting it in the GraphQL context. 3. Ignoring input validation, and how to handle user input safely. Asterisk the problem asterisk GraphQL doesn't automatically validate user input beyond basic type checking. Failing to validate user input can lead to asterisk security vulnerabilities asterisk SQL injection, cross-site scripting, XSS, etc. Asterisk data integrity issues asterisk invalid data being stored in the database. Asterisk unexpected errors asterisk if the database or business logic expects data in a specific format. Asterisk code example, without validation. Asterisk vulnerability asterisk the email field could contain arbitrary HTML, leading to XSS. The name field could be an overly long string, causing database issues. Asterisk solution, input validation, using a validation library. 1. Choose a validation library asterisk popular options include asterisk Joy, object schema description language and validator. Asterisk validator.js, a library of string validators and sanitizers. Asterisk Express Validator, if you're using Express middleware-based validation. 2. Define validation schemas asterisk create schemas that specify the expected format, length, and type of each input field. 3. Validate in resolvers asterisk before processing user input, validate it against the schema. If validation fails, return an error to the client. Asterisk explanation asterisk. Asterisk create user schema, defines the validation rules for name, min/max length, and email, must be a valid email address. Asterisk create user resolver. Asterisk validates the input using create user schema.validate, input. Asterisk if error exists, throws a GraphQL error with a descriptive message. This error will be returned to the client, indicating the validation failure. Asterisk if validation succeeds, creates the user with the validated value. Asterisk key takeaway asterisk always validate user input. Use a validation library to define schemas and enforce data integrity. Return informative errors to the client when validation fails. 4. Authentication and authorization. and how to secure your GraphQL API. The problem GraphQL, by itself, does not handle authentication or authorization. It's up to you to implement these security measures. Failing to do so can expose your data to unauthorized access. Authentication, auth and verifying the identity of the user, example logging in. Authorization, auth determining what a user is allowed to do, example accessing specific resources or performing certain actions. Code example, without security. Vulnerability anyone can query secret data and access the sensitive information. Solution, authentication and authorization, using JWTs and context. 1. Authentication, JWTs. Use a library like JSON WebToken to generate and verify JSON Web Tokens, JWTs. When a user logs in successfully, generate a JWT containing user information, example user ID, roles. Return the JWT to the client. The client includes the JWT in the authorization header of subsequent requests. On the server, verify the JWT and extract the user information. 2. Authorization, context and resolvers. Pass the authenticated user information, extracted from the JWT, through the GraphQL context. In your resolvers, check if the user has the necessary permissions to access the requested data or perform the requested action. If not, throw an error. Explanation 1. Login function, simulates user login. On successful login, it generates a JWT using JWT.sign. The payload includes user ID and role. 2. Context function, extracts the JWT from the authorization header. Verifies the JWT using JWT.verify. If the token is valid, it decodes the token and adds the user ID and user role to the GraphQL context. If the token is invalid or missing, it returns an empty context. 3. Secret data resolver. Checks context.user_ID to ensure the user is authenticated. If not, throws an authentication required error. Checks context.user role to ensure the user has the admin role. If not, throws an unauthorized error. Only if both checks pass, the resolver returns the secret data. Client example, setting the authorization header. Key takeaways implement authentication and authorization before deploying your GraphQL API. Use JWTs for authentication and store user information in the token payload. Pass authenticated user information through the GraphQL context. Enforce authorization rules in your resolvers by checking the user's permissions. Consider using libraries like GraphShield for more declarative authorization policies. Never store sensitive information directly in the JWT payload. 5. Lack of monitoring and error handling, and how to gain visibility. The problem GraphQL can mask underlying issues if you don't have proper monitoring and error handling. Silent failures or performance bottlenecks can be difficult to diagnose. Without monitoring you might not know. Which queries are slow. Which resolvers are causing errors. How many requests are being made to your API. Whether your API is under attack. Solution, monitoring and error handling. 1. Logging log requests, errors, and performance metrics. Use a logging library like Winston or Pinot. 2. Error reporting *. Use a service like Sentry or Bugsnag to track and aggregate errors. 3. Performance monitoring. Use tools like Apollo Engine, now Apollo Studio, or New Relic to monitor query performance and identify bottlenecks. 4. Custom error handling. Implement custom error handling in your resolvers to provide more informative error messages to the client. 5. GraphQL validation. Enable GraphQL validation to catch errors in client queries before they reach your resolvers. Explanation. Console.error logs the error on the server side. This is crucial for debugging. GraphQL error propagates an error to the client. The extensions field allows you to add custom error codes and HTTP status codes. Yoga.logging configure GraphQL Yoga's built-in logger, which has different methods that can be used to log to console. Key takeaways. Implement robust logging and error reporting. Use tools to monitor query performance and identify bottlenecks. Provide informative error messages to the client. Configure your GraphQL server to handle errors gracefully. Example GraphQL error JSON response. By avoiding these common GraphQL mistakes, you can build more robust, secure, and performant GraphQL APIs. Remember to focus on client needs, optimize data loading, validate user input, implement authentication and authorization, and monitor your API for errors and performance issues. Good luck.